Okay, we will start to do the revision paper now. First of all, I want to remind everyone that how to call out the machine. So we go to machine and under mute, then you should be able to see this over here. Okay, if you cannot see, then you will use manage list, and you will then use the browse command, browse, and you should be able to go down to CNC machines. Below CNC machine, there is one folder called Singapore Poly. So click this one and OK. So now once you are in, the things should be appear to be something like this. The files are something like this. So what we need is add this to the right, and then just green tick will do. Okay, so that is how we call out the machine. So first of all, call out the machine. Okay, now we have to merge the files. So file, merge. So file, merge, and I will go to my folder, and here you should go to all files and select the file that you want. Okay, so click on this one, then we say open. Okay, here we have the file. First of all, let's go to inspect whether the view is correct. So you see from here, from the front, you will see that this is our 0 point, and we go down to cut like that. So you see from the top is like that, isometric is like that. So apparently, so all are being okay. So once after we have done that, we'll go to the left, go to properties. Okay, so continuing, we have this go under files on the left, nothing to change over here, 2 settings. So now we have to see what the program number we are asked to have. So let's go to the test paper. The number we have is, we are asked to use these numbers 1331 for top-up group 1. Okay, so we'll go to here and type in 1331, and then as per normal, we'll click on use step, use 2-step pack and colon. Then we go to edit this number 2024, edit this. Again, we will see this value from the test paper, which is over here. Okay, the cutting speed is 60, 0.05, and 400%. So we go into Mastercam and go to change this value, 60.05 and 400. So with that, we'll click green tick and we'll move on to the next tab. The next tab is stock setup. Well, we have to see the raw material size also now. So the raw material size is over here. Okay, here 150 times 100 times 42. This is X, this is Y, this is Z. So we'll go to this X 150, the Y is 100, and the Z is 42. Okay, so after we key in all this, the next thing we want to do is the facing amount is 0.5. So this value will raise up the G5 raw material by 0.5 mm. So when we do the facing, we'll cut from Z 0.5 up to 0. And we want to display the raw material, so activate this. Or if not, later then you can use this stock display to display the stock. That will make it easier to see how much you are removing and all that. So with that, we are done. green tick. Okay, so the raw material is here, the workpiece is here. So now we are ready to start. So first of all, we'll do facing. Again, what you have to do, you can see from here. Okay, first of all, you will have to do facing. Facing amount is 0.5. Okay, and we are using zigzag high-speed loop. So face, and we don't have to do anything, just green tick at this window. And next, we'll define our tool. Okay, we have no tools currently, so right click, create new tool. We are going to create a face mill, followed by next. So you can check the values over here from this page. So the tool number 1, face mill, diameter 63, material is carbide, number of threads is 5 threads. So we go to diameter 63. So this also 63, but the angle is 0. And when you enter this, you will see the graphics of that cutter having 63 mm. So the rest of the value we don't change. So continue to the next. Tool number 1, that is correct. How many threads? So we can check the paper. It says that it is 5 threads. And we can now calculate the speed and the feed. Calculate. Then after that, don't forget coolant on. Okay to that. Then after that, finish. Checking once more. To number 1, 5 threads. Material is carbide. So we calculate and coolant on. So with that, we have done. Finish. So the tool appears over here now. Next, cut parameters. As I said just now, the paper mentioned that we are going to do zigzag, and move between loops is high-speed loops. Then we will not be doing any finish facing, so we'll cut to the size, cut to the exact depth. Depth of cut, we are cutting only 0.5 mm, so uncheck this. Linking parameters, 50 on top, uncheck retract, 5 mm on the feed plane. Now this values also is included in the paper. Okay, so this line here. Okay, 50 absolute, 50 mm absolute. Feed plane is 5 mm from the surface, cut surface, which is the same as the incremental say. Okay, incremental. So we are cutting from 0.5 mm absolute. We just now purposely leave 0.5 mm above the G54. So we cut down to G54. So with that, we are done. So green tick. And now this is the tool path. Okay, next we will move into the next operation. Next is OptiRough. If you read this, next is the OptiRough. Okay, we have done finished this A already. Now we go to B, OptiRough. Okay, so these are the things that was given to us. Okay, the next operation is OptiRough. But before that, I have to create a rectangle. Okay, so you may also want to use a different plane. So now let's say I want to have a level 2, which I call it boundary. And with that, I continue to use rectangle. Okay, the rectangle is the same size as the raw material. So this corner here is, since the material is 150, half of that is 75. This width is 100, so half of it is 50. So press on spacebar, type 75, 50, referring to this corner here. So enter. So now this is our first corner. So now we have to define the second corner. Press the spacebar again. So that corner minus 75, comma, minus 50. Enter. So that green line represents the boundary of our machining operation for OptiRough. So with that, green tick. So we'll go to toolpath, OptiRough. So according to the paper, the wall thickness is 0.2, floor is 0.1, and then we have to define our workpiece. Click on this. So as indicated here, triple click will be select the solid body. So click 3 times and enter. So toolpath control, we'll use this one, the boundary, select, and then with the wireframe loop, I will select one of these lines. So once I click one, all the four lines are highlighted. Green tick with that. Now I will have to go to use tool number 2, and then also after I define tool number 2, I will have to change this value here. Cut feed is surface speed, this one is 240. Cut feed is 4,000, and punch rate is 150. So enter all this value in. Then we move on to the next cut parameters. Then step over 10%, step down 100%, and step up 10%. The backfeed rate is 8,000 mm per minute. Okay, so with that, we'll go to the next. Well, nothing to do over here. So next is that step. From 0, we want to go down to minus 35. The whole workpiece is 34, but we want a bit of cut a little bit down to give us a clean and sharp corner. So linking parameter 50, no change over here, and then we just green tick. So now the machine is computing the toolpath. Okay, here we are. This is the toolpath. So if you see from the top, something like this, and if you see isometric, it's something like this. But anyway, these toolpaths are a lot, so it is occupying the wheel. So I select all, and I use this icon to hide away all the different toolpaths. Okay, so we move on to tool number 3, which is tool number 3, operation number 3, pocket milling. Okay, pocket milling, and we are ramping using the ramping method. So we'll go to so we will go to here, select pocket, and we'll change to use solid loop, and then now we will select the two pockets, one here on the left and okay, one here on the right. Okay, so these are the two pockets that we want to do now. So green tick, and tool number is now the pocket itself 13 mm wide. This is 13 mm. So what is the size for the end mill that we want to use on this pocket? So we can take a look at the tools that is available to us. The next is possibly, it is a roughing tool. So roughing, and the pocket is 13 mm. So this cutter size is 10. This one cannot. This is too big. Then you can argue that the other are too small. So this is the nice one. So we will just go into Mastercam and create tool number 3. This is 16 mm anvil. No, sorry, 10 mm anvil, and 10 mm anvil with number 3. Number of flutes is 4. Material is carbide. So we are okay with this. Calculate, and then we go down to coolant and okay. So that we are done. Finish, and we'll go to cut parameters. And for this pocket, we want to leave 0.2 mm on the wall, but nothing on the floor. Okay, 0.2 mm on the wall, nothing on the floor. Then followed by the next is roughing. So we want to use constant overlap spiral with 50% step over percentage. Then we have entry motion. We are using ramp in this case. How to ensure that there is no that the tool will ram onto the workpiece is to make use of this angle. If you don't use, the value is 0, so it will just keep going up and left and right on the pocket, but it never go down. So to make sure that it ramps down, we say auto angle. Mastercam will compute this angle on how deep it goes, or what is the angle that it should go. Then help us with the angle calculation. Finishing, no finishing yet. Depth of cut, again we can take a look at the handout. Maximum roughing step is 5, so we enter 5. Not the handout, the revision paper. So 5, and keep tool down whenever possible. So linking parameters, 50 on top, uncheck retract. Flip plane is 5 as per normal. Now from 0, I want to go down to absolute minus 10. The pocket itself is 10 mm deep. Take a look at your revision paper. You will be able to see that it is 30 mm wide but 10 mm deep. So with that, we will go down and green tick. So I made a mistake, so I have to go back. It should be incremental 0 to incremental minus 10. Okay, so now regenerate. Okay, so this is the tool path. Alright, so now from here I will go down to the next operation, the 4th. Finish the 2D contour. Okay, so before I do that also, I will go to do wireframe, and I will go to silhouette boundary, and I will select the workpiece, accept, okay, it's done now. So with that, silhouette boundary created. So now I go to toolpath. We go to contour, and we'll use this loop and select the line here. Okay, this line is at G54, but later we'll change it to below. Okay, so green tick here. The tool that we're using for this is tool number okay, it is a finishing tool. this is the finishing tool. So we check at the table. It is a finishing tool. So this is finishing. So it is a big diameter. Okay, so we'll use this tool. Create tool. Anvil. And this is 16 mm in diameter. And tool number 5. 6 fruits. Material is carbide. So we calculate the speed and feed, followed by coolant on. So with that, green tick. So our tool is now here. Cut parameters. This is finishing already. So we'll use the paper here says that the paper mentioned over here that we are using compensation by computer by left, and whenever there's a loop, a closed loop, we'll use these values and this. Okay, later you take note of this. Okay, so now we'll go to we are still using computer finishing, so nothing to be left behind. Depth of cut, activate depth of cut, and finishing. So one cut we finish all. Lead in, lead out. So we're using perpendicular 100% as I highlighted just now. Overlap is 1 mm. Then we have a linking parameter, 50 on top and check on retract, 5 fit plane. So now we are cutting down to minus 35. At the top of the stop is 0. We are cutting down to minus 35. Okay, so with that, green tick. Okay, so we will now continue. Okay, next we have cut over here. Next, I want to remove or polish the surface over here. We have actually done finished. Or let me show you this. Or before that, I saved it first. I file, save as. So this one, let's say I save as. Okay. Okay, so the file saved already. Now, I may want to show you this. Okay, so what happened is now this is we'll do machining, facing. Okay, the opti rough. Okay, all the opti rough finished. So now we are polishing the finishing the outer diameter, the pocket and the outer diameter. So after all this is done, you see what happened is now this face here we have left behind some material. The wall also have some left behind. The wall left behind is 0.2 mm. This we left behind is 0.1 mm. So we need to finish these two dimensions, two sides. Okay, so now with this, I will continue to do the next operation. The next operation is E from the paper. E. So we'll go to uh, um, okay, we'll go to contour, click on contour. Then I will use solid, but I will change to line edge. So remember that cutter is on the left, so I want to select these two lines. So one is going up. When we go up, cutter on the left, we are removing this part of the material over here. So select this. So this is the direction. Then after that, it will come to here. Also, when it goes down, cutter on the left. This is our cutting direction. So these materials here will be removed. Okay, tool. So this is the finishing tool. So I can now repeat this tool number 5. Okay, that is also a finishing tool, and it's also the biggest diameter that we can have. You see, we have quite a bit of materials left behind over here. So the bigger the diameter, the more we can remove. Then cut parameter. So again, this is finishing, so nothing to be left behind. And depth of cut, no need. We'll just one cut to go down all the way. Okay, lead in, lead out. So now again, I want you to pay attention to this this segment here. We'll use lines that tangent 100% of the tool diameter. Okay, nothing else. So we'll just go to perpendicular, and no radius, because this is open loop, so also no overlap. No, we are using tangent 100%. So copy from left to right. So this also 100%. Okay, because the question says that we are using tangent 100%, so I use tangent 100%. Okay, so another thing we want to take note is this drawing here. Okay, the distance here is 130. This is 440. This minus this means 90, or 45 on the left, 45 on the right. And then we are using a 16 mm end mill. 45 on the left, 45 on the right. 16 mm end mill will not be able to finish the whole floor, all this area in one go. So we have to do multi-pass. And multi-pass, how many passes is required? The multi-pass is that we want to have 75% of the cutter diameter. 16 mm end mill. So I will have to, let me do the calculations from Mastercam. Okay, multi-pass, activate. And if I say the spacing is 0.75 times 16 mm, it is 12 mm. So we calculate just now is 45, meaning that I need to have 4 cuts. 4 times 12 is 48, and the width totally is 45. So we will cover that. If we use 3 passes, 3 times 12 is 36. So we still left behind some materials because we are going to remove 45. So this is 48. So this is okay, but cannot use anything less. Linking parameter, 50 on top, 5. This one again is incremental from the line that I pick to the line itself. Just now, as I say, our wall, our opti rough, we will leave 0.1 mm behind, and we want to remove only this 0.1 mm. So top of the stock is 0.1. I will cut to 0. Okay, and both of this incremental. So green tick. Okay, so with that, we are now moving to. Okay, now let's continue with the next operation, F, or operation 6. This one now we are going to do this finishing of the pocket. So I copy this and paste below. And this, of course, we have to change the parameters. First of all, we have to change the tool number 7. Tool number 7 is the one that is finishing. It's also 10 mm MU. So we initialize the speed and feed. Cut parameters. Now we are doing finishing, so nothing to be left behind. Roughing, we are not doing roughing now. We are doing finishing. So finish. We will still be using computer. Keep tool down. Lead in, lead out. The paper can tell us with line perpendicular, and the values are being 25% for the length and 25% for the radius. Then I copy from left to right and overlap 1 mm. Okay, so that move on to the next depth of cuts. Since this is finishing, one cut will finish all, so no need. Linking parameter is uncheck retract 5 0 minus 10. So now should be alright. So let's go and green tick. Regenerate. Okay, so now the next operation is spot drill. So we go to drill these 2 holes. Okay, drill. It will ask us to indicate where the holes are. So indicate first of all this hole, second one, this one, and green tick. Okay, 2. So we now have to create a new tool, the spot drill. If you look at the diagram, we are doing this spot drill. So eventually we have to work out with a diameter 12. So the spot drill itself cannot be smaller than 12. Alright, so we go back to, okay, so spot drill. Next, so we go to take a look at the paper, and we have a tool number 12, which is 16 mm spot drill. Number 11 cannot, you can see that just now, because that is we have to spot drill at 12 mm. So we can only use 16. Okay, 16 mm. Okay, so with that, next, and this is tool number 12. So tool number 12, and this is high speed steel. Then we calculate the speed and feed. Coolant on. With that, this is okay, so we continue. Then cut parameters is this one, nothing to change. Linking parameter 50 on top, retract 5 incremental. Top of the stock is 0, absolute. So we can now this plane is exactly where our G54 is. So this one, I want to cut to 12. So my value can only be minus 6. Okay, so I will cut to, I want to cut 12 mm countersink. So with diameter 12, the angle being 45 degrees, so my height, my depth is 6 mm. So green tick with that. And okay, the next operation is pipe drill. So maybe I want to cut and paste, copy and paste, so I don't have to select the holes again. But of course we have to change. First of all, we have to change the tool. The tool, I want the hole itself is a 10 mm thread, but it cannot be 10 mm. So when we look at the data, there is a trace drill of 8.5. Okay, so right click, create new tool. There's a trace drill of 8.5. So I'll go down to look for or type in 8.5. Okay, so this is the drill itself, 8.5. So we type in 8.5. The rest of the information is provided for us. Next, it is tool number 13. So type in 13, and it is high speed steel. Calculate coolant on. Then the next is here. This is to be pack drill, and 50% for the pack, as indicated in the question paper itself. Okay, so with that, I say finish. Then with that parameter, I have this calculation already, 4.25. Linking parameter, 50 on top, 5, and then top of the stock is 0. Down to how much? Down to how much? If you look at the drawing itself, okay, so possibly you look at this from here to here is 20. So from here to here is 20. So this is roughly the depth of the hole. So I want to say minus 20, but I also need to include the conical part of it. So I calculate this using a calculator, and 8.5 diameter, I should add another value 2.55 below. So green tick. So altogether 32.55. Alright, so with that, green tick, and let me see one more thing. Did I initialize the speed and feed? I think no. Reinitialize speed and feed. Okay. So check once more. 4.25 okay. Linking parameter okay. So green tick. So regenerate. Okay, the last operation for the first side. Again, I want to copy and paste. Copy and paste below. This time round, of course, again, I cannot use the same tool. I have to change a new tool. Right click, create new tool. I need to create a tab this time round. So next. So what we need is M10. M10 times 1.5. M10 times 1.5. So this is the tab that we want. Next. And this is tool number 14. So type in 14. And material is HSS. Then and coolant on, and calculate. No, this one no calculation. The spindle speed is 200. We change this to 200. Okay, and this one we change to rigid tapping cycle. Okay, rigid tapping cycle. Then followed by spindle speed is 200. Yeah, we'll do. Okay, finish. Right click, reinitialize. Okay, so that I move on to the next tab. I think green linking parameter 55 0. How deep am I going down to? So if I look at the drawing, it says 15 mm, so minus 15. And the question also mentioned that it is bottoming tip. That means this is not conical. So that should be no need to add extra values onto it. So with that, green tick and regenerate. Okay, so that finished the first side of operation. So we will save the file again. And currently the NC file name is P. So I want to change the NC file name to your admission number. So just enter your admission number here and green tick. So all of this will be changed into this NC number. Okay, so with that, we will finish off this save again. So we will stop here. Then the next video we'll go to operation 2.